Hello students! Today we're going to talk about the differences between physical and chemical properties and physical and chemical changes. First of all, a physical property is any characteristic of a material that can be observed or measured without changing the composition of the substances in the material. The composition is what it's composed of, what it's made of. So when you finish seeing a physical property, you still have the same chemical formula, not a new substance. For example, if I tell you that this pen is blue, when I'm finishing measuring that it's blue, it's still a pen. It hasn't changed into something else. So the color is a physical property. When I weigh this pen and feel how heavy it is, or put it on a scale and measure the mass, it's still a pen. It hasn't changed into something new. It's still the same substance, so that is a physical property. If I took the temperature of this pen, once again, it's still a pen. So the temperature is a physical property. Some examples of physical properties include the following. First of all, viscosity is the resistance to flow. For example, honey is a very viscous substance. When you go to pour it, it barely pours and drips out slowly. It really resists flowing. Another word for viscosity might be the thickness. Right? So honey is very viscous. You've heard the saying, slow as cold molasses. Well, that's because molasses is viscous. It resists flowing. Motor oil has a high viscosity. Another example is conductivity. When, for example, a metal wire is able to allow heat or electricity to flow, so that copper wire is conductive. It has the property of conductivity. When we finish putting the heat or electricity through that wire, it's still copper. It hasn't changed into something else. Therefore, that is a physical property. Whether something is malleable or not is another physical property. Malleability is the ability of a solid to be hammered without shattering. The way you remember something is malleable is you take a mallet and hit it, and then it flattens it into a thin sheet, and that's how you remember what malleable means. Hardness means a harder material can scratch a softer material. So when it's finished scratching something, for example, you take a rock and scratch a piece of glass, the glass is still glass even if it's in little scratched pieces, and the rock is still a rock, so that is a physical property. Now, melting point and boiling point are ones that people often mistake as chemical properties, even though they're actually physical properties. The melting point is the temperature at which a substance changes from a solid to a liquid. Think about water or ice melting into liquid water. That's solid ice turning into liquid water. However, ice has the formula H2O. Water also has the formula H2O. It is still the same chemical substance. It hasn't changed or turned into something new. So the melting point, the temperature at which it changes, it's still H2O. That is a physical change and a physical property. The boiling point is the temperature at which a substance changes from a liquid to a gas. For example, when water boils, once again, liquid water and water vapor, the gas form of water, are both H2O. So it's not something new, it's a physical change. Finally, the density is a ratio of the mass of a substance to its volume. It's how much it weighs for its size. And density is another physical property, because mass, when you weigh something, it's still the same substance. And when you figure out the volume of something, how big it is, it's still the same substance. And then you just divide those two numbers, so the density is a physical property. By the way, density can be used to test for the purity of a substance. A very pure piece of silver will have the exact density of silver. A piece of silver with, say, some iron mixed in will have a density different than the density of pure silver. A physical change occurs when some of the properties of a material change, but the substances in the material remain the same. So, as I've told you before, a phase change, phases are solids, liquids, gases, and plasma. We're not studying plasma, but the three normal phases of matter are solid, liquid, and gas. And when you change from one phase to another, that is a physical change. And melting, boiling, etc. are examples of phase changes. Now let's talk about chemical properties. A chemical property is any ability to produce a change in the composition of matter, what it's composed of, what it's made of. Chemical properties can only be observed when the substances in a sample of matter are changing into different substances. So when you finish seeing a chemical property, you have a new substance with a new chemical formula. You do not have the same thing. So for example, flammability is a chemical property. Flammability is a material's ability to burn in the presence of oxygen. So let's say you have a log. Well, when you go to see if the log is flammable, you have to set it on fire. And when it finishes burning, you don't have a log anymore. You have ashes, you have water vapor, you have carbon dioxide, but you don't have a log. So don't have a piece of wood anymore. You have ashes. So that is a chemical property, the flammability of the wood. Reactivity is how readily a substance combines chemically with other substances. Well, when it finishes reacting, it's made a new chemical formula, a new compound. And so it is not the same thing anymore. So that would be a chemical property. All of those, when you see a chemical property, you're seeing a chemical change. This occurs when a substance reacts and forms one or more new substances. Evidence of a chemical change, so how do you know if you had one? It can include a change in color. Now, this is not perfect because some physical changes will change color. For example, if you paint a rock, it's still a rock, but now it's blue instead of rock colored. And so that would not be a chemical change. For example, if you melt an ice cube, it goes from kind of white colored to clear. And once again, that's still not a chemical change. So it's not perfect. But if you see a color change along with some of these other changes, this is how you know a chemical change has occurred. For example, if you produce a gas and not from boiling. For example, if you react baking soda and vinegar, what happens is the baking soda and vinegar react together and produce carbon dioxide bubbles. And that's all the bubbles you see that are formed when those two react. That is an example of a production of a gas without actually getting hot and boiling. Another example is the formation of a precipitate can indicate that you've had a chemical change. Now, what's a precipitate? It is not precipitation, rain. This is a totally different meaning. This is an insoluble solid, a solid that will not dissolve. So for example, let's say you've had milk that has gone past its date, it is way over, and you go to pour it down the sink. And you pour this stuff down the sink, and there are chunks in the milk. Right? What has happened is the bacteria has produced an acid that has reacted with the chemicals in the milk, and it has produced a precipitate, a solid that won't dissolve. That's those nasty chunks that you see in the milk. And so that is a chemical change because a precipitate has been formed. All right, so now let's take a minute and figure out if each of these are a physical or chemical change. Let me give you a little hint. Any sort of cooking, baking, grilling, anything like that is actually a chemical change. You're like, wait a minute. When I have a steak and I cook a steak, it's still a steak. How is that a chemical change? Well, if you think about the pink steak before you cook it, and the brown steak after, it's a very different substance. The taste is different. The texture is different. You have a steak that you can't just uncook. You can't reverse it. Now, that's not a perfect example, but many chemical changes are harder to reverse. So any sort of cooking kind of example is going to be a chemical change. Pause this video, take a few minutes, and answer each of these questions. If you don't know where to get started, continue watching the video, watch a few examples, then pause the video and try it on your own, then listen to the rest of the answers. Okay, so now that you've had a chance to try this, first of all, cutting grass. Is it still grass? Is it still the same thing? Of course it is. So that is a physical change. If you cook bread, remember baking and cooking. It starts out as this bread dough, which is liquid and runny, and then it produces a gas and the bread rises. There's a color change, and the bread is totally different. It's got a different texture, so that is a chemical change. If you burn a candle, The candle wax actually reacts with the oxygen in the air to produce carbon dioxide and water vapor. That is no longer a candle. It is now some gases that float away in the air. And so that is a chemical change. When you melt a candle, however, the wax goes from solid wax to liquid wax. It's still wax. It's still the same substance. There's just been a phase change. Went from the solid to the liquid phase. It melted. So that is a physical change. If you peel an orange, it's still an orange. Yes, it's in pieces, but you still have the peel, the segments of orange, all that kind of stuff. So that is a physical change. Melting ice, it's still water, it's still H2O. That's simply a phase change, so that is a physical change. When iron rusts, the iron actually reacts with the oxygen in the air, and it produces iron oxide, which is a new chemical. You can't undo rusting, so it is less likely to be a physical change. Now, I guess you can't undo cutting grass either, so it's not a perfect example, but you can't unrust a piece of metal. So iron rusting is a chemical change because it has actually reacted and become a new substance. When you digest your food, let's say you eat a pizza. Well, that you don't have pizza running through your veins. Your body breaks it down into chemicals, and then the nutrients go through your veins. So your body changes it into something other than plain pizza, and that is a chemical change. If you crumple up a piece of paper, it's still paper, so that is a physical change. Shaping metal, if you melt it or bend it and shape it into a new shape, that is still a piece of metal. It is physical. Burning wood, if you burn wood, you can't unburn it. It reacts with the oxygen in the air, so that is a chemical change. Boiling water is a phase change, so that is a physical change. If you iron a shirt, now as long as you don't burn the shirt, if you just iron it, then you have taken out the wrinkles, but it's still cotton. It's still the same substance, so that is a physical change, cotton or polyester or whatever. When leaves rot, they actually react and break down and become nutrients for the soil, so that is a chemical change. And when you grill a steak, that is cooking, so once again, that is a chemical change. Finally, I want to talk about what kind of properties can be used to separate a mixture. Physical properties can be used to separate a mixture, not chemical. For example, a mixture is just stirred together. You have, for example, oxygen and hydrogen. If you stir them together and mix them, that's a physical mixture. It has not chemically reacted to produce water, which is H2O. So that physical mixture can be separated. Now, it'd be very difficult, but it could be done without changing those into something new. So here's an example of how to separate a mixture. Filtration is one way. When you filter a substance, the dissolved substances pass through the filter paper, and the solids are too big and do not pass through. So for example, if you have salt water, if you have dissolved salt, the salt will go right through the filter paper. But if you have solid salt, you've put too much salt in the water, there's leftover salt, the solid salt will be caught in the filter paper, for example, a coffee filter, and the dissolved salt will pass through the filter paper. So that's a way to separate something. So let's say you have some sand and water. Well, if you rinse the sand with water, the water will pass through and the sand will be left behind. Distillation is a way to separate two liquids by their boiling points. If they have different boiling points, they'll separate. Yes, distillation, like say moonshine, all right? So if you have alcohol and water mixed together, then if you will slowly heat them up, the water has a boiling point of 100 Celsius, and the alcohol has a lower boiling point. So the alcohol is easier to boil. So when you distill moonshine, as you begin to boil it, the alcohol, there's like 99% alcohol evaporating and maybe 1% water evaporating. So if you catch the first drips, that's going to be really concentrated moonshine. But then as you go, it's going to be like 98% moonshine, 97, 96. And so after a while, you'll want to stop because that way you'll get the more concentrated moonshine. Then towards the end, you're getting, say, 99% water, so that would be less concentrated. If you will repeat the distillation over and over, it would get more and more concentrated. So that gets really old. So instead, that's why they use the copper coils. And that helps the distillation occur over and over and over so that much of the first part of the liquid you collect when making moonshine will be very concentrated. Another example of distillation is making distilled water, taking the minerals out of the water. The minerals are dissolved, so they'll pass right through a filter paper. But if you boil some salt water or whatever minerals you have in your water, and the water will evaporate and salt or other minerals will be left behind. Well, okay, how do you catch the water then? Well, you've got to put something over the top of that, catch the water, and then let the drips fall back down, and those drips will be pure water.